Northrop's Cygnus XL overcomes a software hiccup. When Northrop Grumman's brand new Cygnus XL lifted off aboard a Falcon 9 rocket from Cape Canaveral, everything looked flawless. But the real challenge wasn't launch. It came days later, when the spacecraft was supposed to perform critical burns to align with the International Space Station. On Tuesday, the mission team noticed something unusual. Cygnus's main engine had shut down early during 2 separate burns. These were essential maneuvers designed to nudge the spacecraft into a precise orbit for docking. Without them, Cygnus risked missing its scheduled arrival, forcing NASA to announce a delay. Initial speculation hinted at a serious propulsion failure. After all, this was the debut mission of the XL version, and an engine issue could cast doubt on its design. But data quickly told a different story. Engineers analyzing telemetry discovered the engine itself had performed flawlessly. The shutdowns weren't caused by hardware malfunction. They were triggered by overly conservative software safeguards. These safeguards act like digital safety nets, constantly monitoring the spacecraft's performance. If a sensor reading strays outside expected ranges, even briefly, the software cuts off the engine to prevent damage. In Cygnus XL's case, the thresholds were set so tightly that normal behavior was mistaken for danger. Once the issue was identified, engineers verified the propulsion system's health and carefully adjusted the parameters. With the updated settings, Cygnus could continue its journey safely. With the software updated and confidence restored, Cygnus XL resumed its approach to the International Space Station. By early Thursday morning, it had maneuvered to within just 30 feet of the orbiting laboratory. At this stage, the spacecraft hovered, waiting for the station's crew to take over. Astronaut Johnny Kim, operating from inside the ISS, extended the Canadarm2 robotic arm, while astronaut Zena Cardman provided critical support. At exactly 7:24 a.m. Eastern Daylight Time, or 11:24 UTC, the robotic arm successfully grappled Cygnus, marking a turning point in a mission that only a day earlier seemed in jeopardy. Once captured, the spacecraft was carefully positioned at the Unity module, one of the International Space Station's key docking ports. 16 bolts then engaged, creating a secure connection between Cygnus and the station. For the crew aboard, the relief was immediate. More than 10,800 pounds of supplies and science experiments had safely arrived. Inside the cargo bay was a diverse shipment. Essential items included food, oxygen, and nitrogen tanks, ensuring the station's life support systems remain fully stocked. Critical spare parts were delivered as well, including components for the urine processor that recycles wastewater into clean drinking water, a vital system for sustaining long-term missions. But the cargo went far beyond basics. A new navigation aid was aboard, designed to be mounted outside the station to help future spacecraft guide themselves during docking. Even more exciting were the science experiments, hardware to study semiconductor crystal growth in microgravity, which could transform electronics manufacturing, and a cryogenic propellant demonstration, aimed at solving one of space exploration's hardest problems, how to store and maintain rocket fuel on long missions. Beyond overcoming a software glitch, this mission was historic because it marked the first flight of the Cygnus XL. Unlike earlier versions, this upgraded spacecraft features a cargo module extended by 5.2 feet, or about 1.6 meters. That design change may sound modest, but it delivers a major impact. The XL can carry 33% more cargo than before. In practice, that means heavier loads, fewer resupply flights, and more efficient use of rockets like SpaceX's Falcon 9. For NASA and its partners, this upgrade is a logistical breakthrough. Instead of spreading supplies and experiments across multiple smaller missions, one Cygnus XL can handle a wider mix of essentials and research payloads. This flight's 10,827 pounds of cargo is a prime example of the new capability. With ISS operations expected to continue for years, the ability to deliver more in one trip reduces cost, planning complexity, and scheduling risks. The XL upgrade also demonstrates how commercial partners evolve their spacecraft step by step. Increasing capacity isn't just about stretching the hull. Engineers had to refine propulsion systems, rebalance power and thermal management, and recalibrate software to account for new weight distributions. The very software glitch that delayed this mission is part of those growing pains. By identifying and fixing it mid-mission, Northrop Grumman proved the XL is adaptable and resilient. Looking further ahead, the XL points to the future of deep space logistics. Missions to the Moon and Mars will demand cargo freighters capable of hauling heavy, complex payloads while operating autonomously for long durations. The Cygnus XL mission showed us that even when a spacecraft faces unexpected setbacks, quick thinking and smart adjustments can turn potential failure into success. It proved that software is just as vital as hardware, and that upgrades like XL's expanded cargo capacity are key to the future of space logistics. Please don't forget to like, share, and subscribe. Thank you for watching. See you next time.